Okay, so as advertised, I'm going to have a little talk here about the plasma membrane. The plasma membrane. Okay, so cells. Cell theory. They are cells. All have plasma membranes. And this includes prokaryotic cells, such as bacteria. Eukaryotic cells are different in that they have internal membranes as well as an external one. So, to think of the plasma membrane, we shall imagine ourselves being outside in the cold and rain. Maybe there's snow or hailstones. It's not much fun at all, but when we get to our house, it's nice and cozy and warm. So there are walls of our house that protect us from the bad weather outside. And in the same way, the cell, the internal part of the cell, can be different from the external part of the cell. Except when it comes to the cell, the walls are not made of bricks. The walls are what's called plasma membranes. And we are going to see that the plasma membranes are made of what's called phospholipids. Alright, so yeah, we want to keep out, the cell wants to keep out some things. Alright, the concentration of some chemicals outside the cell is going to be higher, and the cell is not necessarily going to want those chemicals inside. But the cell does want some things inside it. The cell wants amino acids, glucose and lipids. Okay, these are the molecules of life for one reason or another. Glucose for energy, amino acids to make proteins, and lipids for various functions, including making the cell membrane itself. And cells need to get rid of waste products. Yeah, so there's going to be a barrier, but there are going to be things moving across that barrier, and proteins will help in that. Selective permeabilities. Yeah, so that's a big feature of plasma membranes. There are some things that can move by diffusion, like oxygen and carbon dioxide can move by diffusion across cell membrane. Also water can. But if we're talking about selectively permeable membrane, not everything that's out there can get into the membrane. It can get into the cell. So here we've got an example of what's a selective membrane, or this would be if you open your window, you can let air in. So it's selectively permeable, this mesh. It allows air in, so it's a nice day, you open up your window, but it doesn't let in flies or mosquitoes or certain big nasty things into your home. So we can say selectively permeable, just like the cell. So what is it that explains how a phospholipid bilayer can occur and form a barrier? We have to know first that oil and water do not mix. As you can see here in this picture, you try to mix water and oil, it's just not going to happen. Alright, looks like it's been stirred up here, but they form globules, right? They're not mixing. It's not like sugar and water. They're not going to mix. Because why? Because oil is made up of what's called a hydrophobic. It's hydrophobic. This likes water. Hydrophobic. Hydro's water. Phobic means don't like. Alright? Hydrophobic. So the interior of a plasma membrane is like that. These can I use this? These squiggly lines. Oh, sorry. These lines here, which are squiggly, they're all, and I'm calling it in red right now, they're all hydrophobic. Water hating, water fearing, water hating. Don't want to be near water, alright? These hydrocarbon chains. Whereas you have the heads, which I'm calling in red right now. Maybe not. Anyway, the heads are hydrophilic and they will face the water. So the water will be here, or the aqueous solution will be here, out here that I'm colouring. and also inside the cell here. So here's the barrier. This is the phospholipid barrier. Alright, so if we zoom in a little bit, what are plasma membranes composed of? Plasma membranes are composed of a lipid bilayer. A phospholipid is a lipid with a phosphate group attached. So here we can see that this top part here is charged. Alright, it's got a net charge. Unlike the tail here, which is all these bumps mean carbon, hydrogen, saturated fatty acid. These are unsaturated fatty acid. The hydrophobic tails don't like water. The hydrophilic head, because it's charged, it likes water. And this is why you get this spontaneous, when phospholipids are left, you get the spontaneous formation of a bilayer, which is a barrier between inside and outside. However, we know that there are things that cells need, like I mentioned earlier. They need glucose, they need amino acids. So there are proteins in that bilayer that help to transport amino acids in and glucose in, but also would look to expel waste products. Okay, so this model of a cell membrane is called a fluid mosaic model. Fluid, because it's fluid, it means it moves, alright? Just like water sort of flows and the surface of a water flows. This thing is believed to flow. Also, mosaic is a pattern, and it's the proteins inside that fluid membrane that sort of look like a pattern. So it's called the fluid mosaic model. Okay. And there's cholesterol in the membrane as well. So cholesterol is an important component of cell membranes. They regulate, I believe cholesterol regulates just how much flow there is, makes sure there's not. It's an essential molecule in cell membranes. So as I mentioned, there are transport proteins in the cell membrane, and I guess we can say there's like, here we've just got three. The channels, there's a channel there that looks like a molecule from the outside that's going to the inside. So this could be facilitated diffusion. Diffusion is where there's a high concentration moving to a lower concentration. Or you could have this one here, which is pumping something in. And because this uses energy, ATP to ADP, there's a very high likelihood that it's pumping something that's scarce on this side of the membrane into something that is rather abundant here. In other words, it's going against this concentration gradient. It's called an ATPase pump. It's called active transport. Alright, or else it could be pumped out here. Looks like there's no ATP involved in this one. So perhaps this is also like simply happening by diffusion, or this one. So for example, I think sodium channels are a bit like that, nerve impulses. Okay, that's it. Hope you enjoyed it.